Alright, this video is about how to solve differential equations with given initial condition values. So I'm going to start with example 1, pretty basic. The equation is 6x squared plus 6x plus 2, and that's your differential equation, and your initial value is -1 comma 2, and that's given. All right, let's see how this works. So step number 1, you have to separate your variables, and remember that the y and dy they have to be on the left side, and the x and dx they have to be on the right side. So in this case we have dy over dx on the left side. We don't want that dx. So what we're going to do, we're going to multiply both sides by dx. And in that case, we're going to get 6x squared plus 6x plus 2 on the right side times dx. Now look carefully, you don't have any y variables or dy on the right side, and you have only dy on the left side. There's no y, if you noticed, but that's okay. By the way, dy I can express as 1 times dy, which is exactly the same thing. So that was your step number 1. Now step number 2, you are going to integrate both sides of your equation. You know how we're allowed to differentiate both sides of the same equation. We can also integrate both sides of the equation. In this case, you have the integral of 1. And what's integral of 1? In other words, what derivative of what equals to 1? The derivative of x, well, in this case it has to be in terms of y, so that would be y. So the integral of 1 dy equals to y. Well, normally we add c because it is an indefinite integral, but instead of adding c to the left side and again another constant c to the right side, we're just gonna combine them both and add that the constant to the right side. Let's see, integral of 6x squared gives you the 6x cubed over 3. The integral of 6x is 6x squared over 2. The integral of 2 is the 2x. And as I said, you're going to add the constant c to the right side. Let's clean it up a little bit. So we get y equals 2x cubed. Y equals 2x cubed. And then 3x squared, positive 3x squared, plus 2x plus c. Beautiful. Now we're going to use this initial condition, the point that they give you, the coordinates are -1 comma 2, and we're going to, I'm just going to put it right here. We're going to plug it into our equation. So we get 2 equals 2 times, instead of x you're going to put -1 cubed, plus 3 times -1 squared, plus 2 times -1 plus c. So the reason you did that, because you want to find the constant c and finish your equation. So let's see what we get. 2 equals -2, positive 3, -2 plus c. Now it's just simple math here. -1 plus c, and I believe we get c equals to 3. So now let's put it all together, and we get y equals 2x cubed plus 3x squared plus 2x, and what did we get for c? Positive 3. And that's it. So you just got your original equation, y equals 2x cubed plus 3x squared plus 2x plus 3. And if you want to check, you can take the derivative of this equation, and you'll see you're gonna get dy dx equals 6x squared plus 6x plus 2. That's exactly what you started with. But because they wanted us to use this specific value, so that means your function, your graph goes through -1, 2 point. That's why your C value is this specific value, C equals 3. It could be 5, it could be -10 or -billion. Why? Because when you take the derivative, you get 0. And you're going to end up with the same differential equation you started with. But no, in this case, they do give you the initial condition value. So that's very important. All right, so let's try now number 2. dy dx equals to 1 plus 12 x to the power of 3 over 2 square root of x. And remember what I said, the rule number 1, step number 1, you need to isolate your variables. So the dx has to move to the right side, so I'm going to multiply both sides by the dx. And I get 1 plus 12 x to the power of 3 over 2 over 2. Instead of square root of x, I'm just going to put x to the power of 1/2 and times dx. I now have y on the right side, so I can just now integrate the both sides of my equation. And let's see what happens. Again, same situation. So the integral of dy, it's just y equals, well, this one is a little messy, but we can do it. We can certainly do it. Let me just show my work on the right side here. I'm going to copy this integral 1 plus 12x to the power of 3 over 2 to x to the power of 1/2 dx. I'm going to probably express this fraction. I'm just going to split it into 2 fractions. So 1 over 2x to the power of 1/2 plus 12x to the power of 3 over 2 over 2x to the power of 1/2. So I hope you understand what I did. Nothing special here. So the common denominator is 2x to the power of 1/2. Now let's try to simplify this a little bit, see what happens. And we get, I'm not integrating yet. I'm just trying to make it easier for myself so that I can integrate. 1 over 2 x to the power of 1/2. It's on the bottom. I want to move it up, so I'm just gonna do that, and that becomes 1/2 x to the power of -1/2. 12 over 2 is 6, so it's positive 6. Now, what do we do with exponents when we have this division? So we subtract exponents. So we get x to the power of 3/2 minus 1/2 gives you 2 over 2, which is 1. So it's just 6x, and you end up with this easy expression. Easy, I mean it's easy to integrate. The integral of 1/2 x to the power of -1/2 equals to 1/2 x to the power of -1/2 plus 1/2 times the reciprocal 2 over 1, because you divide by 1/2. So we're going to multiply by the reciprocal of 1/2, which is 2 over 1, plus, and the integral of 6x is 6x squared over 2. I'm not going to do plus c here yet. So we get x to the power of 1/2 because you cancel the 2. Then you get plus 3x squared. Excellent. So that's what I'm going to actually move up here. So we get y equals, we already integrated the left side. That was pretty easy. And on the right side, we got x to the power of 1/2 plus 3x squared. And remember what you need to do. That's extremely important. You add c to the right side. Now we need to find that c. And by the way, I almost forgot. The initial value is f of 0 equals to 2. So the x value is 0, the y value is 2. So let's plug it in to find the value of c. We get 2 equals 0 plus 0 plus c, and that's 2. So the final equation, you can put y equals, I decided to use f of x equals y. Actually, there's a reason, because when you look at the initial value, it says f of 0 equals 2. It doesn't say g of 0 or k of 0. So we could we should have done the same thing in problem number 1, because if you remember the initial value, I didn't really, yeah, I did say that, f of -1 equals to 2. So no big deal. So we get f of x equals, that's the equation, so it's x to the power of 1/2 plus 3x squared plus 2. And now you are done. If you don't like x to the power of 1/2, you can always express it as the square root of x. Now let's move on. Number 3. Let's make it a little bit harder and see if we actually get it. dy dx equals x squared plus 2x over 2y, and my initial value is f of 0 equals to 2. Alright, so again, step 1, isolate the y dy from the x dx, so separate them. Well, you're going to multiply both sides by dx, and I can show my steps separately. So you get x squared plus 2x over 2y, but times dx. And then in order to get rid of the 2y on the bottom right here, you can multiply both sides by 2y. Because when you do that, you get rid of that denominator on the bottom, and you get 2y on the left side. And that was my goal. So we get 2y times dy equals to x squared plus 2x. Let's put it in the parentheses, otherwise it's going to look weird. And that's it. Now we can go ahead and integrate both sides of this equation. And we get 2y squared over 2, or you can just say y squared right away, equals to x cubed over 3 plus 2x squared over 2, don't forget, plus c. So we get y squared equals x cubed over 3 plus x squared plus c. Now let's find that value of c. By the way, before I do that, I want to get your attention here. So the point is 0, 2. So if you noticed, the y value is positive. So that's very important. Please remember this fact, and I'm going to come back to this. So let's find that c. We're going to plug in the 2 for the y. And we get 0 cubed over 3 plus 0 squared plus c. And it looks like c equals to 4. Then I get y squared equals x cubed over 3 plus x squared plus 4. Now, we still need to solve for y, because we want to express our equation in terms of x, but it's supposed to say y equals f of x equals to something in terms of x. Right now, it doesn't look like a function. It says y squared. Not allowed to have that. Then what am I supposed to say? Y equals plus or minus? But it's not a function. Well, remember what I just told you a minute ago. I said, what is your initial value? The initial value is 0, 2. So the y value here is positive. So that means I'm not going to consider y equals negative, the square root of all of that. I'm going to consider just y equals positive, the square root of x cubed over 3 plus x squared plus 4. And that's going to be my final solution. If you don't believe me, just plug it in. Plug in as 0 for x and see if you get 2. You're not going to get negative 2. So I hope that makes sense. Right, next. Let's actually try that's number 4. Dy dx equals to x to the 4th y minus 2. The initial value is 0, comma 0. All right, same idea. I'm going to separate my variables. I will probably divide both sides by y minus 2 to have my y minus 2 on the left side, and I'm going to multiply both sides by dx. I hope that makes sense. I just showing two steps at once. And I'm going to rewrite it actually. I don't like dy over y minus 2. I would like to see 1 over y minus 2 dy equals x to the 4th dx. And go ahead and integrate both sides. Now, 1 over y minus 2. What would you say if you just had 1 over y dy? So in other words, the derivative of what equals to 1 over y? And I hope you said ln, the natural logarithm of a y, because that's what it is. But it's not just y in your denominator, it's actually y minus 2. Still the same idea. Derivative of what equals to 1 over y minus 2? It's the natural logarithm of y minus 2. And I'm not worried about the chain rule here, because the coefficient of y is a 1. So this integral that gives me ln of, please use the absolute value of y minus 2, because the natural logarithm of the negative number doesn't exist. So we need to be careful and just say the absolute value of y minus 2 equals to x to the 5th over 5 plus c. Now, we need to use the initial value of 0, comma 0 to find the value of c. All right, so we're going to do ln of 0 minus 2. See, that's exactly what I meant. So that would be negative 2, but the ln of negative 2 doesn't exist. It's undefined. But the absolute value of negative 2 is 2. So I'm going to put the ln of 2 equals to x to the 5th over 5 plus c, but x is also 0, so let me just plug in 0. So then what do we get? We get ln of 2 equals to c, and that's the value of c. Now I'm looking at this equation. That's what I got, right? That was my last step before I found the c. So then we get ln of y minus 2 equals x to the 5th over 5 plus ln of 2. Now we need to clean it up a little bit, because we need to simplify or we need to solve it for y, right? Well, I guess we need to involve some algebra 2 here. First of all, what I suggest is probably to rewrite this equation as e to the power of x to the 5th over 5 plus ln of 2 equals to y minus 2. I hope you understand why I did that. So I just decided to rewrite it in exponential form. The reason is simple. I'm trying to solve this equation for y, so somehow I have to pull out that y from here. So this would be the only way. Now, still, I can add the 2 now to both sides, but I don't really like the way it looks, so I really need to make it a little better. So what we are going to do, when I say better, I mean probably simplified. So it's plus ln of 2, so I can express it as times e to the power of ln of 2. We can do that, right? So when you multiply two terms like this and you have the same base, you add your exponents, right? So that's what I did here. I multiplied e to the power of x to the fifth over 5 by e to the power of ln of 2. And now like you can drop the absolute value sign. So we get, by the way, what is e to the power of ln of 2? The algebra 2. That just gives you the 2, because this big base equals to the little small base on the top, so it's just 2. We get e to the power of x to the fifth over 5 times 2. I would like to put in front, it's my coefficient, equals to y minus 2, and therefore y equals 2 e to the power of x to the fifth over 5 plus 2. And that is my f of x. And now I'm done. It looks cleaner and it looks much, much better. But there's something that worries me. Remember when I said you can drop the absolute value, and then we had it right here. And we said, well, we can just express it as y minus 2 instead. But if you remember, what's the definition of the absolute value? In this case, you can say it is equal to y minus 2 equals to this, 2e to the power of x to the fifth over 5, or, just because we're talking about the absolute value here, y minus 2 equals negative 2 e to the power of x to the fifth over 5. So it's either positive or negative. And when you solve, I don't have enough space here, so I'm going to erase the last part. So then we get y equals 2e to the power of x to the fifth over 5 plus 2. That we got from this equation. Or, now let's use the second equation. We're going to get y equals negative 2e to the power of x to the fifth plus 2. I'm sorry. Plus 2. Yep, plus 2. All right. And now which equation are we supposed to choose? Well, back to our initial value. If you remember, we had f of 0 equals to 0. So that was your initial value, 0, comma 0. So now it's just like the previous problem we had here. Remember, we had a choice. Either use the positive square root or negative square root. So we did use the initial value to confirm that it has to be the positive square root. Same idea here. It's 0, comma 0. So plug in 0. Let's use the first equation. So you get 2e to the power of 0 plus 2. E to the 0 is 1, and the result is 4. That's not what we have. We're supposed to have 0, comma 0. So let's use the second equation. You get negative 2e to the power of 0 plus 2. And e to the 0 is 1, and the answer is 0. So that tells you that this is supposed to be your final answer. So, in other words, your function is negative 2e to the power of x to the fifth over 5 plus 2. So now we're done. I'm going to do one last problem, and it says dy, that's number 6, dx equals y minus 1 over x squared, and f of 2 equals to 0. So same idea, we're going to separate the variables, so I'm going to multiply by dx and probably divide by y minus 1. So I get 1 over y minus 1 equals, since x squared here is on the bottom, so I can actually express this as y minus 1 times x to the power of negative 2. You see? So then when I divide by y minus 1, I get rid of that, and I just have x to the power of negative 2. but I multiplied by dx as well. So, oh, here I'm missing dy. Now that looks better. So that's it. Now let's integrate both sides. Well, it looks almost like the last problem. The integral of 1 over y minus 1 gives you the natural logarithm of y minus 1. And this one would be x to the power of negative 2 plus 1 is negative 1. Over negative 1, we can just put the negative plus c. Now we need to find that c. So let's use this initial value. So x is 2 and y is 0. So we get 0 minus 1 is negative 1, but we're using absolute values, so we get ln of 1 equals negative. We can rewrite it as negative 1 over x to make it look normal. We get negative 1 over 2, because the x value is 2, plus c. Now, what's ln of 1? The natural logarithm of 1 is 0, because e to the power of 0 is 1. So that is 0. And on the right side, we have negative 1/2 plus c. Therefore, c equals to positive 1/2. Okay, so let's see. We get ln of y minus absolute value, y minus 1. Please notice that I'm using this equation. Ln of y minus absolute value of y minus 1 equals negative 1 over x plus c, but c is 1/2. So that's what I get here. Now I need to, remember, solve for y, so I have to isolate the y somehow. So I'm going to use the same the strategy as before. So it's e to the power of negative 1 over x plus 1/2 equals to absolute value of y minus 1. Now, it's an addition sign here, so we can split it into e to the power, oops, it's not negative, e to the power of negative 1 over x times e to the power of 1/2 equals to y minus, absolute value of y minus 1. You can express e to the power of 1/2 as the square root of e, but that's not necessary. Now, absolute value. So then we get y minus 1 equals either e to the power of negative 1 over x times e to the power of 1/2, or y minus 1 equals to negative e to the power of negative 1 over x. Let's say we get y equals, so we simply add 1 to both sides, and that's what we get. I circled it, but it doesn't mean that's my final answer. I'm not sure yet. And add 1 here, so you get negative e to the power of negative 1x times e to the power of 1/2 plus a 1. And remember, your initial value was 2, 0. So let's plug in the 2, and we get e to the power of negative 1/2 times e to the power of 1/2 plus 1, and you're supposed to get 0. Do you get 0? E to the power of, you add these guys, and you get 0. No, that's 2. That doesn't work. So let's cross it out. And just in case, let's check this one. So y is 0 equals negative e to the power of negative x is 1/2, 2, I'm sorry, negative 1/2 times and plus 1. So we get 0 equals negative e to the 0 plus 1. Aha, we do get 0. Perfect. So that means this equation right here that we got is our final solution. So that's how you solve the differential equations with given initial values. I hope this makes sense.